So learners, we're looking at the following information. This is the mechanical analytical component of grade 11 and grade 12. So this page consists of different types of sections. So I'm going to look at the different types of sections this page consists of, and we're looking specifically at 6 different sections. So section number 1, and I want to explain with some pictures, is what we call a full section. So if a component like this, right, this is a machine component, there's a hole inside here, and there are 4 bolt holes on the edge of that component, which has been drilled. So this is metal, that's nothing, that's air because it's a hole, that's air because that's a hole. So you take a hacksaw and you cut this perfectly in half and you remove the one side. So when you remove this side or that side, the saw left some marks here. Now these are the marks that the saw actually left, right? It was perfectly in the middle, it wasn't cut there because that's air. There you can see it's an opening, there it's an opening, and there's an opening. The rest of it, solid metal, and that's where the saw actually made contact with the metal. So we call these cross-hatching or sectional lines. So when you cut right from top down to bottom, it is called a full section. Right? To give you another view of a full section, I want to look at the following components. Here we have a machine component. There's the mark where I'm going to cut it. That is a cutting line. I take the hacksaw and cut through the metal right in the middle. This side has been taken away. It leaves me with hatching lines there and hatching lines here. Nothing here because it's open, an open section, right? And when you view it from the front, that is what the 2D is going to look like. The same thing here, there it cuts through the middle, there you're going to cut through that middle, there's a hole there. That is basically what it refers to, a full section. When you cut the whole thing from side to side, from top right down to bottom, is called a full section. We are going to look at the next one, which is the half section, and I'm going to highlight that half section. Now you're going to find significantly that there's a component and only half of it has been sectioned. The other half remains in full. And this is what we call a half section. So when you are faced with a drawing which only has cross-hatching lines on the one side, and it possibly could be either the left or the right side, doesn't matter, that is called a half section. It's not like the full where it's cut right through. To show you how the half section is created, I'm going to take you to the activity on the next page. So when you have a component, you're not cutting from this side right through to form a full section. No, you start here, but you're only cutting a quarter. So that quarter has been removed now. This still remains untouched. Right, that's why we have still the full section there, the full part there, and only this part here where it has been cut will get the cross hatching. There's nothing here being hatched because it's an open space, which means that there is a hole there. The same thing here, if you cut out a quarter of this flange, and then you will find that there's a hole in the middle, no hatching there, you're only touching or make contact with the metal up here on top, the bottom still remains intact, no hatching lines there. That is classified to be a half sectional view, which is either top or bottom half, depends on the cutting section, or left or right, depends on which section you cut out. We proceed to the part section. In the part section, it's very important to understand that the whole component, or even half of the section or the component, has not been sectioned. But this wavy line indicates that it is only a part that has been cut out to specifically show detail, right? To show specific detail. So anything associated with a wavy line and hatching lines can be regarded as a part section. That is how you identify part section, and I want to show you what it looks like in reality. So here you have a shaft, is a center line. That is an S-break. It means it continues that way, but we're not showing the entire shaft because it's too long. So it's an S-break, means it continues. There is a key in a key slot, which we spoke about. The key slides in the key way, but I want to show the key slot here. So the wavy line opens up, and that part has been cut away to have a full view of the key that is shown. So wavy line associated with part section. We go to the opposite side of the page where we have an aligned section. So we underline an aligned section, and I want to talk about an align. So this shape here does not have what we call a symmetrical shape, where that part, the left, looks exactly like the right. It's slightly on a slant. So the cutting line takes the form of the component on the slant as it is. There's the cutting line, so I'm going to cut right there through the middle and down. And that is what it's going to be like when I am going to have it cut. Through a hole, no sectioning there. That's the hole there, no sectioning there. There's a keyway, no sectioning there. You only see that corner there that becomes visible. And then of course you transfer this onto that center line there to be able to show this clearly. That there now reflects as an opening there. That there is the part where it's cut and it's projected onto the center line, and that is how you draw an aligned section. Right? It looks like the full section, but the full section has a straight line, either vertically or horizontally. The aligned section has a line that forms to the shape that we are cutting. Let me look at an example. Here we have a few examples of components with holes inside and an aligned section, and it is transferred onto the main line so that you can have a full view of it, and there it has been shaped according to the component. It's off center here. That is what it looks like after it has been cut. Open section through a hole, open section through a hole, but the bottom part is closed. Here you have another example where it is vertically done and slants and vertically coming out this way. A hole, no sectioning there, a hole, no sectioning there, a hole, no sectioning, only on the parts where the saw actually would make contact with the metal. We now look at the removed section. Basically tells us that it has been taken out. So when you look at any component like this, or you look at a component like that, just the one view, you would not be able to say what this shape looks like here of the hook. So what the draftsman has done is that he has taken the shape here and put it outside so that the maker can see what shape that part there is. Right? You can see it aligns directly outside. So that part there has a bigger component or bigger part here than the part on this side here. And the same here, that little section there looks like that there, that's the shape of it. This part here has the shape of that part that you see there. All you need to remember, it has been taken out, it has been removed outside to show you the shape. That is basically how you get to a removed section, and I want to look at an example, a quick example of the removed section. Is that you have a component, and that part we don't know what the shape looks like, but the draftsman has taken it out and has taken the liberty to show us what it looks like. It is always hatched because it comes as a section part. You have to cut it open to see a section part. That's why it's hatched. Similarly, like this one in this example here, we don't know what the shape is like there. There it has been removed to show us. Here it has been removed to show us what shape that part there of the component is. And the last section that we will be looking at is the revolve section. The revolve section is very similar like the remove section. The only difference is that it has not been taken out, but it's actually placed exactly inside the drawing. Like that would be placed inside, that would be placed inside the drawing. For example, here it shows that shape would have been removed as a remove section if it was there, but because the draftsman drew it inside the component of the part, like here, that is a cylindrical shape or a circular shape. This now becomes a revolved section. So the revolved and the removed are very similar. The only difference is that the revolved is drawn inside the component and the removed has been drawn outside. The various cut sections to see the shape has been drawn outside of the drawing. And that basically concludes the part on sectioning. Those are the 6 sectioning information that you need for your analytical question for grade 11 and grade 12. I hope you enjoy it.